Okay, we're gonna go ahead and do 6.2. For the most part, it's super easy because one-to-one functions means for every x value, there's one y value. There's never duplicates of either. One-to-one means that it doesn't repeat either x or y. Remember, if your y repeats, before that was a function. If your x repeated, it was not a function. One-to-one functions, it's just every one thing has one line coming from it, both sides. So, since every input only has one output, this is a one-to-one function. It's that simple. Determine whether the function is one-to-one. It's not, because this range value has two values. So, no, because the relation between input and output is not clear from the given function. No, because there are two different inputs, 30 hours and 35 hours, that correspond to the same output. For the following function, determine whether the function is one-to-one. So 2, 5, -7, and 1, all those are good. 6, 9, 14, and -17, those are good. Nothing can repeat. Like, no x's can be the same, no y's can be the same. If an x and a y are the same, that's okay. But you can't have repeated x's or repeated y's. 1, 1, 2, 2. So our x value 1, 2, 3, 4. Great. 1, 2, 14, 71. Great. But this is what I meant, like, you can have the same x and y value, but you can't have a repeated x or a repeated y. So this is a 1, 1. Determine whether the graph of a function f is given. Use the horizontal line test to determine whether the f is a one-to-one function. So looking at this graph, if I was to draw a horizontal line now, because that's to check if the y repeats any, it's not going to cross it more than once. So yes. I'm sure there's one that's not if I put one that is. This is one of our graphs that we're going to get into more on the next couple lessons. So it gets exponentially closer to it, but it's never the exact same. So this is a one-to-one function. Okay, here, find the inverse of the one-to-one function. State the domain and range of the inverse function. So you're changing your output to your input. So we're going to have these pointing to those. So they switched them up. So like 161 needs to go to Amy, not Sarah. This would just be flipped. You're changing your input and your output. Continue. What is the domain of the inverse function? So instead of it being the output, it is now the input. So it's going to be those. And I bet the next one is, what is the range of the inverse function? So instead of it being the input, it's now, so it's going to be Amy, Hans, Carl, Franco. Next. Find the inverse of the one-to-one function. So another one just like it. So instead of these being our output, they are now our input, and 110 goes to 20. About clicked the wrong one. Continue. So our now domain is 110, 150, 190. And our range is going to be 20, 30, 40. These are not bad. Find the inverse of the one-to-one function. Okay, I'm going to have to sit down to do this. I'm just going to take every single one of these and flip them. So it's going to be -9, 3, -5, 4, 10, 5, 11, 6, 2, 7. But I need to sit to type it. Okay. So, -9, 3. Be sure you keep all your commas and your parentheses in order. -5, 4. 10, 5. 11, 6. And 2, 7. Okay. Make sure I didn't put a period instead of a comma in there. Make sure I have all my commas. I think I got it all. Let's look at. The domain of the inverse function, so I'm gonna take all the original y values and make them be my, domain now, or I can just take what I just typed and take this first one, so -9, comma, -5, comma, 10, 11, 2. And then I'm gonna do 3, 4, 5, 6, 7. That was nice. And again. So 3, 10. -12, 7. 1, -8. -7, 3. And 15, -12. It's just kind of hard to look at. Check parentheses and commas. 3, 10, -12, 7. 1, -8, -7, 3. 15, -12. Whew, I feel like I'm going cross-eyed looking at this. So 3, -12, 1, -7, and 15. Oh. 10, 7, -8, 3, and -12. The graph of a one-to-one function f is given. Draw the graph of the inverse function f of -1. For convenience and as a hint, the graph of y equals x is also given. So what they're saying is your inverse function is always going to flip across the y equals x line because you're flipping your x and your y values. So like we're going to have 3, 2, and then you're going to have 2, 1. This is -1, 1, so you're going to have 1, -1. And then -3, -3, that point's still there. And it's going to line up exactly across from it. So there's a problem like that that's on your final, and I call it my squid problem. Okay, here's our algebra part of this. Because when we do the inverse of these, there's supposed to be a very interesting thing that happens. Okay, so f of g of x, we're putting the g function into the f function, so I'm going to have 2, and then instead of x, we're going to put the g function in here. Plus 3. And I'll go ahead and minus 6. So instead of x, we have our g function. So 2 times x over 2, 2 divided by 2 is x. 2 times 3 is 6 minus 6. Those are gone, so it's x. So given any values of x that need to be excluded from f of g of x, select the correct choice. Was there anywhere that would made it undefined or not real? No. Oh, now then, g of f of x, so we're going to have our g function. That makes it easy. We're going to have 2x subtract 6 all over 2 plus 3 because our x is on top of the 2. So we're going to reduce first. So 2 divided by 2, 6 divided by 2, 0. So that's x. And then I didn't click it, did I? X. Enter. They're going to ask if anything needs to be excluded. Since our x isn't in this denominator, it's not going to make it undefined. So no values need to be excluded. Are the functions f and g inverses of each other? Yes, because they both equal the same thing when we simplify them. 6 over x, which is going to be 6 over 6 over x. Woo! Remember, keep, change, flip. So this 6 on the top is like 6 over 1. You change from this division right here to multiplication, and then we flip our bottom right here to x over 6. I should have used a dot. And then 6 divided by 6 here is 1, so it is x. Okay, here, however, x cannot equal 0 on either of these, because if it was 0, it would be undefined. So we put 0 in there, because that would mean a 0 is in the denominator, and we cannot have that. Same thing, because these are the same thing. 6 over 6 over x. I guess I didn't need to erase it then. So 6 times, and you flip it to be x over 6. 6 divided by 6 is 1. So it is still x. Is that highlighted? And then same thing, since x is in the denominator of both of these, if we put 0 in it, it would make it undefined. And then are these inverses? Yes, they are. I removed this one because it just seemed like it was going to be a lot of extra work. Okay, the function f of x equals 16x is 1 to 1. Find the inverse of f and check the answer. So when we're solving for an inverse, and it's wrote like this, what you do, here, let me go ahead and say we have y instead of f of x. So when we're finding our inverse, we swap our x and our y. So I'm going to have x equals 16 over y. And then we solve for y again. So we have y equals x over 16. So we're not going to put y in, we're going to put x over 16. The domain of f is negative infinity, but remember this one's f. And this one's our inverse because it has the negative right there, okay? So our domain, there's nothing that should be excluded. There's nothing that's going to make that undefined or not real. So negative infinity to infinity. And then our range, there's nothing that's going to be excluded out of that. So negative infinity to infinity. Negative infinity to infinity. I feel like there was more of these on the old edition. I guess I didn't put them on here. Okay, your domain and range of your inverse, remember when we were doing the points and we'd swap the x's and the y's? Exact same thing here. So our domain of our inverse is the range of our original, and then our range of our inverse is the domain of the flop. So this one's, but it happens, they're both the same on this. So negative infinity to infinity. I sat down, that chair's squeaking. Whoops, I misclicked. Infinity. And then they want us to graph it. Okay. I think the kicker on this, yes. So let's go ahead and do our 16x. So 0, 0 is our y-intercept. 16x would be up 16 and right 1 because that's our slope. And then our other one, we have 0, 0. And our inverse was x over 16, so that's going to be 1. It'd be up 1 over 16. But they also want us to graph y equals x. When you do y equals x, it's 0, 0, and then your slope is 1 over 1. Don't forget your y equals x. And that's that lesson.